Hello and welcome to our app demonstration. Our app is called the Golf Swing Analyzer, and as you might have guessed, it helps golfers analyze their swing for practice.
This is the home screen that we've made for our app. Here the user can record a video of their swing or upload one from their computer. So I'll upload one and you can trim the video using this little tool here. You can pause it, you can hit play, and you can submit it for analysis. On this screen that comes up, you can see the breakdown of your swing and how it's been analyzed. So you can pause the video, you can play the video, you can change where it plays from. And if you look down here, it gives you the feedback for the three elements of your swing: the setup, the backswing, and the forward swing.
Our application utilizes three key aspects to provide users with feedback to improve their golf swing. First is the graphical user interface, allowing the user to interact with the program. Next is the machine learning model, which allows us to analyze and provide feedback to the user. Finally is the structure of our program that maintains order and control by using a model view controller setup.
This is our control screen using tkinter in Python. While I was building this, I ran into a challenge early on with trying to get video to work with tkinter because the built-in methods weren't working for us to be able to change the video, slice the video, pause and play. So I had to switch over to OpenCV, and I send the video into a video class that splits it up into its frames and sends frames one by one into this screen. And tkinter is able to display each one as an image and update every time tkinter updates, making a seamless video. Also enabling us to be able to pause on a specific frame, to resume that frame, and to be able to slice the frames so that we only get frames coming between two values. And the widget that we made for that is actually a custom tkinter canvas widget that I created from a template that I found on Stack Overflow. And using mouse detections and tkinter events, was able to choose two frames to slice using that widget and the information that comes back from it with the values of where the start and end are. Also with this part of the app is the ability to record video and save video, also using OpenCV, using similar methods.
On the analysis screen, we ran into a problem where the GUI would not run while we were processing the video. To fix the problem, I learned the basics of threading in Python and implemented a single thread.
We built our own machine learning model which analyzes pre-qualified golfer movements and categorizes them by stage and quality. To do it, we used a pre-built pose model called MediaPipe to detect all the joints of the body. This pose model will return a series of values for each joint, namely X, Y, and Z coordinates. Then each coordinate is saved in a CSV file and then passed to the machine learning library called scikit-learn. This library uses an algorithm that takes subsamples of the dataset and finds a pattern for each predefined category. This model is key for our application and it will be used to score the final user performance.
Using the OpenPose machine learning model, the golfer's body points are mapped on the user-provided video. Our program uses the locations of specific body points to split the video into three separate stages: setup, backswing, and forward swing. Each individual video is then passed through our MediaPipe machine learning model for its respective stage. The learning model returns a category of good, medium, or poor, along with the probability for each frame of each video. This is where we ran into one of our biggest challenges: understanding how to interpret the returned data. I felt that it was important to take into consideration the probability of the returned data. And so I chose to take account of each category, good, medium, and poor, and multiply it by the average probability for each category. I then look at the remaining counts of each category and select the category with the highest number of counts remaining for the final category. The final category for each stage is then returned to the user along with advice related to that respective stage.
At first, our idea was to track the golf ball, but that quickly proved to be too advanced. So then we wanted to create a mobile application that utilized a front and side view, but we realized that it was too ambitious in the time that we had.
For our application, we decided to use a model view control structure, and I took the lead in designing how all the different parts would interact with each other. And we put all the video processing and machine learning models in the model category. Our two screens went in view, and the controller handled the data interchange between the two. And I've drawn up this loose diagram of how our program works. You can see that all the different aspects of our program are able to work well together, and it really made implementing new features and updating things, it made that a lot more manageable.
Developing the goal twin analyzer was fun and challenging. Throughout our project, we learned a variety of skills, including converting an idea into a functional program by using flowcharts, utilizing tkinter to implement a graphical user interface, building our own machine learning model, designing and maintaining a dataset, solving real-world problems using algebra, teamwork, and using encapsulation to simplify future updates.